Okay, the plan is for me to have these quizzes graded and hand back to you tomorrow. It is also for me to have worksheet 3 graded and hand back to you tomorrow so that you can ask questions, because I know there were a couple confusing questions on worksheet 3 for y'all. Today and this week we are learning something new every single day. Yep, I told you at the very beginning of this unit, it's a long unit. It's a lot of information. If you look at my board, you will notice you have homework due every single day this week. All right? You need to do it. If you don't do the homework, especially what I noticed on this quiz, the people that did not do worksheet 4 did not do well, or worksheet 2 did not do well on the back of this quiz because you had no practice. The reason I give you homework is so that you can practice these things. For instance, today I'm going to probably talk almost till the end of the bell. You're not going to have time to practice this unless you do the homework tonight. Your homework tonight is going to be in Schoology. It is going to be 5 questions, all drag and drop. You do not have to turn in a paper tomorrow, but you might have to show work on like the side, so just have a scratch paper ready. Okay? All right. So today we're going to learn all about chords. And this was just on your quiz. What is a chord? It's a segment inside a circle. Yes, ma'am.
I think I looked at pencil bag in the last page. Can I look at it?
Can you wait till we do the notes and then I'll let you go? Yeah. Okay. All right. And so a chord is just a segment inside of a circle. All right. It has endpoints. It should not have arrows. Wait, don't throw that away. Valerie or Naomi. Okay. So the first property, we're going to learn 3 properties today. The first property we are going to learn is that congruent central angles, do you agree that this angle is congruent to that angle? Congruent central angles will have congruent arcs. Write that down. And by the way, you do not need your computers right now, so you can like close them about 45 degrees. Give me a 45 degree angle on that. And congruent chords or segments, but chords is what I'm going to use. What this means is that if these are both 45 degrees, which arcs are congruent here? AB is congruent to DC or AC. So I'm just going to write that right here. Arc AB is congruent to arc CD. Do you agree with that? Now what about the chords? Thank you. What chord, this doesn't show it here, but I want you to draw it. Chord AB, although, yeah, we don't know about AD. AB, and that's a line above it, is congruent to what? Chord CD. So their arcs are congruent and the segments, the lines that connect them are congruent. The segments that connect them are congruent. Does that make sense? Can I change or move this up? So now we're going to apply this to an example problem. Which pair of chords are congruent here? YK is congruent to what? And that H should go all the way to the circle. I don't know why it doesn't. So YK, or you could say KY, is congruent to HA or AH. All right, that's one of them. Good job. Can anybody give me another one? Ooh, louder.
U2 and
HW and
HW. HW is how much? Yeah, do y'all agree H to W? Can y'all see that yellow? H to W is, this is what? 30 right here. Do y'all agree with that? So what's the whole thing going to be? 50. And what is YT or TY? 50. So YT and HW. Can y'all see that? Okay, cool. They're both 50. All right, last one. Anybody got another one? YH is how much? Those are 130 degrees. And what else? How did you get TW? Add everything up, and if I add everything up, I got 50 plus 100 plus 30 plus 50 is 230. And what am I going to do? Subtract from 360, so that gives me 130 degrees. So they're both 130 degrees. YH and TW. And actually there's another one. What else is 130 degrees? K to A. So all three of those you could put two of in any order of that. Does this make sense? How to find congruent chords. Okay. The next property. Can I slide this up, or are we still writing? Oh, wait, one sec. All right. The next property, I'm going to star this one, says congruent chords are, and I don't know why it's such a small blank, I apologize, but equidistant. You're going to kind of have to write small. Congruent chords are equidistant from the center of a circle. What does that word equidistant mean? Equal distance, the same distance. So look at the examples right below it. Which chords are not equidistant from the center? Do y'all agree this very last one is definitely not equidistant from the center? Definitely not. Which one is equidistant from the center? This third one right here, do you agree they're both 8 and 8? That works. Y'all said the first one. Why the first one? It's zero distance. Y'all agree they go through the circle? I mean, through the center? And since it goes through the center, how far is it from the center? 0. So these are both equidistant. What are those? They're diameters. And don't y'all agree the diameter of a circle is the same no matter where it's at? What about this second one? We can't tell. Do we know the distance from the center? I have no idea. So that one we don't know, / it's wrong because I don't know it. Does that make sense? All right, that is the second property of chords. The last property, which is the one we're going to do the most work on. Can we open up now? Okay. The last property states that in a circle, a radius that is perpendicular, what does perpendicular mean? A radius that is 90 degrees to a chord bisects the chord and the arcs. What does bisects mean? Cut in half. If you don't remember that, please write that down to make sure that you know what that means. So if you see a 90-degree angle, whenever we cut something in half, do y'all agree we've done tick marks? If you see a 90-degree angle with a chord and an arc, you can draw tick marks. But the converse of this is true as well. If you see tick marks, what can you draw? A 90-degree angle. So it goes both ways. All right? So we're going to do these two examples together. Number 1, it says TR bisects PI. What does that mean? Which one does it cut in half?
Both.
Not both. PI. TR bisects PI. They don't bisect each other. PI is the one that's cut in half. So I'm going to draw tick marks on PI. Because I have tick marks, what else can I draw? I can draw a 90-degree angle. And you can draw it all the way around or just on one. It doesn't matter. It also tells us PI is 8. What do I know? And NI? 4. And it tells me TN is 3. What does NR equal and TP equal? Why does TP equal 5? Do y'all agree that if I were to connect this, I have a 3, 4, 5 triangle? TP is 5. 5 what? Inches. Does everybody in here agree with that? What if you didn't recognize that it was a 3, 4, 5 triangle? You could do Pythagorean theorem. All right, NR is probably one of the most missed questions every year. Everybody wants to tell me it's 3. Why not? Yeah, TR is not bisected. It could be, but we don't know. But what do we know about TR? It is connected to the center, which means it is a radius. What else is a radius? Do y'all agree TP is a radius? So what's my radius? 5. So if TR is 5 and I know TN is 3, what's NR? 5 minus 3 is 2. That is my answer. Does that make sense? So I'm going to tell you 2 things. Number 1, when in doubt, draw a triangle. I know we're on the circles unit, but you're going to notice every single one of these problems has a triangle in it. Number 2, look for your radius. If you can find the radius, then you are usually going to be able to solve a lot of problems. Okay?
Why did you subtract by 2 again?
Because, no, I subtracted by 3. Because, do you agree this whole thing is a radius? And it's 5? So if we know this side is 3, how do we find that side? Subtract. Yep, that makes sense? Okay, perfect. For this question right here, what do I tell you? What does this mean? Perpendicular, draw your 90-degree angle. And if I have a 90-degree angle, what else do I have? I can draw tick marks. Quentin, you shouldn't be looking at your computer because there should be nothing on it. 90-degree angle, tick marks. Now OR, and by the way, I don't know why this R doesn't extend. Can y'all make that extend all the way? OR is 25. OL is 7. How do I find CL and CA? Triangle, Pythagorean theorem. Where do you see a, how can I draw a triangle? You can do C to O or O to A. It doesn't matter which one. So I'm going to do C to O just because that's what you said. What do I know about C to O? Why is it 25? Because it's a radius. And now, can I just do Pythagorean theorem to find out that bottom? Do I have to do Pythagorean theorem?
No.
Why not? It is one of our triples. It's probably a triple you don't have memorized. So if you don't, just do Pythagorean theorem. It's fine. Remember that 25 is your C. What is the square root of 576? 24 is my B. That is my CL. Do I have any questions on how I did that? What is CA? 48. Do you agree these are both going to be the same thing? So 24 plus 24 is 48. And that is my answer. And it didn't give us units, so I can just leave it like that. Questions? Savian, pick your head up. Write this down, please. All right, I want you to try example 3 on your own. Go. The one on the bottom. Sorry. It doesn't have a number. Just the one on the bottom. Yeah. And then if you could write your answers like I have on my board to kind of help organize that. All right. Did y'all get 51 right here? Okay. Did you get the AB is congruent to CD? So, and do y'all see these 90-degree angles? What can we add to the picture? Tick marks everywhere. So if ACD is 8, what are each of these? 4 and 4. Did everybody at least get FD was 4? Okay. And if FD is 4, what is AB? 8. Did everybody at least get AB was 8? Those two should have been the easy ones. It's the other ones that are hard. I need everybody to look up at my board. Up here when we wrote this, we wrote that if it's perpendicular, a chord bisects the chord and its arcs. So, if this is 51, what is this? Is that helpful information? Is that information that you knew before I said it? Some of you, yes, maybe a lot of us know. So if they're both 51, what is the whole arc AB? 102 degrees. So what's arc CD? 102 degrees. Does that make a lot more sense now? Okay, so your arcs are also bisected, so those can also be the same. Okay? We like that? We're comfortable with that? All right. Can I change it? I want you to do this next, or look at this next one. We're going to do this together. It tells you that the radius of circle Z is 6. ZF is 3. Everybody write it 3. HD is 60 degrees. I want you to find arc CD. I want you to find angle CZH. I want you to find CF. And I want you to find FH. Well, what do I know? Louder. Why is FH 3?
The radius is
Okay.
radius is 6.
The radius is 6. Do y'all agree Z to H? Look up, y'all. Do y'all agree Z to H is 6? So then if this is 3, what's this? Remember how earlier I said it doesn't always bisect it, but it can? This is an example where it does, but it's not always going to do that. All right, good job. What else? CH is also 60. Why? It has the 90-degree angle. What can I add right here? Tick marks. And because I can add tick marks, then they're both 60. So what is arc CD? 120 degrees. Don't forget your degree sign. What is CZH?
60 degrees.
C to Z to H. Why?
The central angle.
It's the central angle, so do you agree they'll be the same? So 60 degrees. How do I find CF? You could. I don't hate it.
It's a 30, 60, 90.
But I think 30, 60, 90 is quicker. You might not agree with that. You might be like, I don't know it. But I do. So I'm going to do right below here my 30, 60, 90 chart. By the way, what's CZ? Do y'all agree CZ is a radius? So it's 6.
Wait, where do you find the 36?
Do you agree that's 60?
Yeah.
What do we know this is?
90.
90. So what do we know this it has to be? 30. Yep, good question. So what do I have in this triangle? What's my hypotenuse? 6. What else do I have? The short leg is? What is my long leg going to be? 3 root 3. And do y'all agree that is CF? And there's my answers. Again, could you have done Pythagorean theorem instead? Absolutely. But then you would have had to do your little tree or your little chart to figure out the simplify the radical. Y'all want to try to do the last one on your own? Let's see what you got. See how much you can get. All right. Did you fill out the information I filled out up here? Okay. So, what do we know first? Say that louder. Yeah, do you agree HL creates a semicircle? So if this is 120, what's CH? 60. And if we know CH is 60, didn't it tell us CH is congruent to HF? So arc HF is also 60 degrees. Well, can I find angle CDA right here? How? Yeah, do y'all agree that 90-degree angle means that I can bisect those? So that means this 60 is bisected, so it is 30 and 30. So 30 degrees. All right, how do I find BD? Yeah, it's a 30, 60, 90 triangle. Well, what do I know about this triangle right here? No, central. It's at the center. Nope. I mean this triangle right here. Why do I know the hypotenuse is 10? Do y'all agree it's a radius? Right. So that is my hypotenuse. So I'm going to put 10 in the hypotenuse spot. So what do I find next? How do I find the short leg? Divide it by 2. Y'all, these rules are not going to go away. If you don't know them, you need to spend some time in tutorials practicing them. And that short leg is what? Do y'all agree that's CB? Well, if CB is 5, what's BH? So what is CH? And if CH is 10, what is HF? Also 10. Does that make sense? Because I know their arcs are the same, then I also know their chords are the same. And then how do I find the long leg? Times root 3. That is my BD. 5 root 3. That's the long leg. There is one more. This is all really, really tiny, huh? It's hard to fit it all in there. Last thing you need to know is how do you find AB? AB is that little bitty thing right there.
10 minus 5 root 3.
I would do, what's the radius?
10.
Minus, what's that long leg?
5.
And you're just going to leave it like that. That's your answer. 10 minus 5 root 3. You can't subtract them. Just leave it like that. Okay? That one was a little weird, huh? Definitely. Your homework tonight is in Schoology. It's due when you walk in tomorrow. It is 5 questions, all drag and drop. Again, you're not going to have to turn in a paper because not all of them require work, but you will want a stat sheet. Please glue this paper onto page 63. And we are done for today.